This is SpaceTime, Series 28, Episode 112, for broadcast on the 17th of September 2025. Coming up on SpaceTime, ancient rocks revealing how a supercontinent broke apart. Scientists confirm water once flowed on the asteroid Ryugu. And a new study trying to pin down the origins of globular clusters. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Scientists examining rare minerals found in Outback Australia have shown how huge tectonic forces tore apart the supercontinent of Rodinia more than 800 million years ago. The findings, reported in the journal Geological magazine, are shedding new light on how rare metal-rich magmas reach the planet's surface. The authors show that niobium-rich Carbonatites rose up from deep within the planet through pre-existing fault zones during a tectonic rifting event between 830 and 820 million years ago, and that ultimately broke up the supercontinent of Rodinia. Carbonatites are rare igneous rocks, known to host major global deposits of critical metals such as niobium and rare earth elements. Niobium is a strategic metal vital for producing light, high-strength steel used in aircraft construction, as well as pipelines, electric vehicles, and is a key component in some next-generation batteries and superconducting technologies and clean energy production. One of the study's authors, Chris Kirkland from Curtin University, says these carbonatites are unlike anything previously known in the Aileron province, and they contain important concentrations of niobium. But by detecting when and how they formed has historically been difficult due to their complex geological histories. The Aileron province is located near Alice Springs in the Northern Territory. Kirkland and colleagues used multiple isotope dating techniques and drill core carbonatite samples that had been in place during a period of continental rifting which preceded the breakup of Rodinia. By analysing isotopes and using high-resolution imaging, they were able to reconstruct more than 500 million years of geological events the rocks had experienced. They found the tectonic setting allowed carbonatite magmas to rise through the fault zones. These fault zones had remained open and active for hundreds of millions of years, delivering metal-rich melts from deep within the planet's mantle up into its crust. Kirkland says this approach allowed him and his colleagues to pinpoint where the carbonatites formed and separate those original magmatic events from changes that happened later in the rocks.
Rodinia is what's known as a supercontinent, so that's a period of time when all the continental fragments of Earth were really all joined together and smushed up together. So you can think, at the minute we've got Africa and America, you can see, the outline of those continents kind of look like they're pretty similar. So if we roll back time, those continental fragments would have come together. So Rodinia is a supercontinent about 1 billion years ago. So 1 billion years ago, we had the supercontinent, this aggregation of all these fragments of crust on our planet, and it's quite important geologically.
And as continental drift happened, plate tectonics took over and Rodinia split apart about 830, 820 million years ago. And there's some interesting evidence of that.
Yeah, that's exactly right. So through time, supercontinents come together and then they break up. But when they break up, interesting things happen with the rocks. We get more mantle material rising through the cratons, that's the crust, and it brings with it metals, and that's kind of important for us going exploring to look for certain resources. So specific types of rock. One specific type of rock known as a carbonatite, because it's a carbonate magma, typically is associated with breakup. So Rodinia was breaking up about 830 million years ago, and that breakup event brought metals up from the mantle, and that's a pretty interesting process because it helps us go and explore for rocks and metals. So we looked at these carbonatites, these rocks from right in the center of Australia. They'd previously been looked at, but they're actually really challenging to understand their age. But using a range of different minerals and isotopic techniques, we managed to get an age out of them at 830 million years. And as we said, that's an important time in Earth's history because it tells us about the breakup of Rodinia. And that's interesting because at that time, we also note that there's niobium-bearing rocks. So these carbonatites are bringing metals with them, and those metals we think are being formed at the same time. So they're being brought out of the mantle and placed into the crust, and that's useful now because we've got a recipe, if you like, for a mineral system. So it helps us to go and explore for these other niobium-bearing rocks, which is an important metal for, high-strength steel, advanced alloys, and green technology like electric vehicle batteries and wind turbines, for example. They all rely on niobium. So having this recipe for this metal is kind of important to help us find more of it.
Do we know how the metal's made deep underground?
Most metals sink, right? We've got a magma that creates a process where you've got fractionate material, so light material will rise up and heavy material will sink down. So the mantle becomes more concentrated in metals, and one of them is niobium. So when you have rifting events, and that's when magmas are rising up from the mantle, it actually provides a mechanism for transferring some of these concentrated metals deep in our planet upwards into the crust where we can access them. And what's specifically interesting is these carbonatite melts are very reactive. They're chemically strange rocks, so they react quite strongly. They dissolve crystals, but then they reprecipitate them or regrow them again. And in that process, they drop out the metal into a range of different minerals, including one that's named pyrochlore. And that's part of the process that enriches the rocks in metals.
The entire Western Australian region is an absolute playground for new metals and unique geology, isn't it?
Yeah, that's exactly right. I think there's a number of different reasons for that. So one is that through time, you get different types of metal deposits forming. So gold, for example, tends to be concentrated in really old blocks of crust. And then you might get events that circulate water and fluids through those rocks, and they tend to enrich things like gold. But then we have other mineral systems which are formed in a different way. For example, when we're getting mantle upwelling events, like we've just been talking about, like in rifting, and those sorts of events would happen away from the older blocks. They tend to occur in slightly younger rocks. I say slightly younger, right? We're talking about a process 830 million years ago. That's actually quite young for Western Australia, where we've got these really, truly ancient pieces of crust. Most of the Yilgarn, for example, is about 2.6 billion years old. That's much, much older, but it's about having this huge amount of time and this ability for rocks and then fluids to interact with each other that allows us to have these enrichment events, creating all these metals that we need for our society at different points in time.
We see this on the surface in the jagged remains of these giant cratons.
Yeah, we do. We absolutely do. So you can find lots of interesting rocks on the surface, but of course, when you want to site a mine, you need to look at things in 3 dimensions. So that's when you start to think about drill core and exploring for rocks deeper under the cover. And that's where we use drill core, and we look at those drill cores to understand the size and the volumes of rocks that are carrying these metals. So it's not just about the exposed rock, it's about predicting in, if you like, 3 dimensions where these volumes of rock occur.
The size of these features is incredible.
Yeah, that's exactly right. Yeah, there's these fantastic geophysical maps that allow us to kind of image through the subsurface. And there's geological structures that run all the way through our continent. It's quite remarkable. There's even one actually very close to where you're talking about that runs almost north-south, and it looks as if it's a massive big crack through our entire continent. And the reality of that is, well, it kind of was. We have these big structures that are where the cratons broke apart and came back together again, and those cracks are the exact places we have fluids. When geologists talk about fluids, they mean magmas, but they also mean water circulation as well, but they mean silica rock circulation, so magmas, and they were pumping up along these long-lived deep fracture systems. These fracture systems can be so huge they tap all the way to the mantle, so they're not just surface features, these are deep features that really tell us about how our planet was put together, and they're the exact places we might get metal enriched. So quite very important for carrying out exploration.
That's Professor Chris Kirkland from Curtin University. And this is SpaceTime. Still to come, scientists confirm that water once flowed across the asteroid Ryugu, and we look at the possible origins of globular clusters. All that and more still to come on SpaceTime. Scientists have shown that liquid water once flowed on the parent body, which spawned the near-Earth asteroid Ryugu more than 1 billion years after it first formed. The findings, reported in the journal Nature, could impact current models of planetary formation, including those describing the birth of the Earth. And the study also overturned some long-held assumptions that water activity on asteroids only occurred during the earliest moments of the solar system's history. The new results are based on tiny rock fragments of asteroid returned by the Japanese Aerospace Exploration Agency's Hayabusa 2 spacecraft, which visited Ryugu on a sample return mission back in 2018. The study's lead author, Tsuyoshi Izuka from the University of Tokyo, says astronomers already have a relatively good understanding of how our solar system formed, but there are still gaps, including knowledge of how the Earth came to possess so much water. Now, it's long been hypothesized that carbonaceous asteroids like Ryugu, which formed from ices and dust in the outer solar system, could be one potential source of Earth's water. Izuka and colleagues found that Ryugu preserved a pristine record of water activity, evidence that fluids were moving through its rocks far later than expected. And this changes how astronomers think about the long-term fate of water in asteroids. The heart of the discovery comes from an analysis of isotopes of lutetium and hafnium, whose radioactive decay from lutetium-176 into hafnium-176 can serve as a sort of clock for measuring geological processes. Their presence in specific quantities in the samples studied were expected to relate to the age of the asteroid in a fairly predictable way. But the ratio of lutetium-176 to hafnium-176 was far higher than expected, and this strongly implied that some sort of fluid, probably water, was essentially washing out the lutetium from the rocks containing it. Now, the most likely trigger for all of this was an impact on the larger parent asteroid of Ryugu, which fractured the rock, generating heat and melting the buried ice. This allowed the liquid water to percolate through the body. And the same impact may well have been responsible for creating Ryugu out of its parent asteroid in the first place. One of the most important implications for all this is that carbon-rich asteroids may have contained and delivered much more of Earth's water than previously thought. It seems Ryugu's parent body retained ice for more than 1 billion years, meaning similar bodies striking a young Earth may well have carried an estimated 2 to 3 times more water than what standard models currently account for, significantly affecting Earth's early oceans and atmosphere. It suggests that the building blocks of Earth were far wetter than previously imagined, and it forces scientists to rethink the starting conditions for Earth's water system and how and when our planet first became habitable. This is SpaceTime. Still to come, we look at the possible origins of those mysterious objects called globular clusters. And later in the science report, a new study finds that the more psychiatric disorders you have in later life, the more likely you are to develop dementia. All that and more still to come on SpaceTime. For centuries, astronomers have puzzled over the origins of some of the universe's oldest and densest stellar systems known as globular clusters, and now they may finally have an answer. Globular clusters are stellar spheres containing thousands to millions of densely packed, gravitationally bound stars. The stars in globular clusters all have a similar chemical composition, and that suggests they were all originally born at the same time in the same stellar nursery of molecular gas and dust clouds. Most galaxies have large collections of globular clusters orbiting them. Our own galaxy, the Milky Way, has at least 150, and a neighbouring big galaxy, Andromeda, has more than 200. But that also opens the possibility that at least some globular clusters are in fact the stellar cores of satellite dwarf galaxies, which were stripped of their outer stars during mergers with host galaxies in a process called galactic cannibalism. Now a report in the journal Nature may finally have solved the mystery, suggesting both options are possible. The new detailed computer simulations also uncovered a new class of stellar object which may already be in our galaxy, globular cluster-like dwarfs. Now, unlike galaxies, globular clusters show no evidence of dark matter, and their stars are unusually uniform in age and chemical composition, traits which have left scientists debating their formation since their discovery back in the 17th century. The new ultra-high-resolution computer simulations known as EDGE can trace the universe's 13.8 billion year history in unprecedented detail, and that allows scientists to watch globular clusters form in virtual real-time in a virtual cosmos. And the simulations found multiple pathways for the creation of globular clusters and, unexpectedly, the emergence of a new class of star system, globular cluster-like dwarfs, stellar constellations that, in terms of their properties, sit somewhere between globular clusters and dwarf galaxies. The study's lead author, Ethan Taylor from the University of Surrey, says the formation of globular clusters has been a mystery for hundreds of years. So Taylor and colleagues used the UK's Dirac National Supercomputer Facility to run the EDGE simulations over several years. Conventional dwarf galaxies are typically dominated by dark matter, with around 1,000 times more of this mysterious substance than stars and gas combined. However, the newly identified globular cluster-like dwarfs appear similar to regular star clusters when observed, yet still contain a significant amount of dark matter. That means that telescopes may already have found them in the real universe, but classified them as regular globular clusters. And this small difference places them in a unique position to study both dark matter and globular cluster formation. And several known Milky Way satellite galaxies, such as the ultra-faint dwarf galaxy Reticulum 2, are likely candidates. Now, if confirmed, they could become prime sites in the search for pristine metal-free stars born in the early universe, as well as new locations to test models for the ever-elusive dark matter. At a resolution of 10 light-years, fine enough to capture the effects of individual supernovae, the authors were able to show that globular clusters can form in at least two different ways, both without dark matter. The next step is to confirm the existence of these globular cluster-like dwarfs through targeted observations with telescopes, including the Webb Space Telescope and upcoming deep spectroscopic surveys. Now, if they do, it could give astronomers new ways to test dark matter theories, and offer some of the best chances yet to find the universe's very first generation of metal-free stars. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study has found that the more co-occurring psychiatric disorders you have in older age, the more likely you are to develop dementia. The findings, reported in the British Medical Journal, compared dementia diagnosis among patients aged 45 and over based on how many psychiatric diagnoses they had. Compared to patients with a single disorder, the authors say the odds of developing dementia were more than doubled for those with 2 disorders and 11 times higher for those with 4 or more. They say it's possible that the presence of multiple psychiatric disorders could be an early sign of dementia rather than a cause of the condition. Boeing and the Australian Air Force have completed the maiden test flight trials of the new MQ-28 Ghost-Bat unmanned stealth fighter 4 months ahead of schedule. The multi-role aircraft are designed as a force multiplier, working with the F-35 Lightning II stealth fighters and the FA-18 Super Hornet fighters, as well as E-7A Wedgetail airborne early warning and control aircraft. The test flights were run out of the Woomera Rocket Range in Outback, South Australia, and from the Tyndall Air Force Base in the Northern Territory. The validation flights tested the unmanned combat aerial vehicles in realistic battle scenarios, including autonomous missions and their ability to operate effectively alongside manned aircraft. They were also deployed in coordinated operations with multiple Ghost-Bats. The MQ-28 also demonstrated advanced data sharing capabilities between crewed and uncrewed platforms, enhancing situational awareness. Each aircraft can carry 2 internally mounted AIM-120 advanced medium-range air-to-air missiles and are equipped with a range of sensors, including infrared search and track systems. And air-to-air refueling capabilities also being looked at in order to extend their range from the current 3,700 kilometres. As well as the Australian Air Force, the Ghost-Bat's also being looked at by the Pentagon for possible deployment with F-15EX Eagle II fighters as additional sensor nodes to help find and target hostile air defence systems. Scientists have found that there are no plant-based food for dogs sold in the United Kingdom which meet the nutritional guidelines for man's best friend's health. They say if you've got your dog on a plant-based diet, you need to add supplements in order to fill the gaps. A report in the journal PLOS ONE analysed the nutrient content of 31 dry dog foods that were labelled as complete, which included 19 meat-based foods, 6 plant-based diets, and 6 veterinary foods designed to be low in protein for dogs with kidney issues. The authors found that the meat and plant-based foods had similar nutritional profiles when it came to proteins and amino acids. But the plant-based foods typically didn't meet the guidelines for iodine and vitamin B levels which adult dogs need. It's important to also note that none of the foods they tested completely met the standards for all nutrients needed by adult dogs. But in many instances, these missing nutrients can be added in supplements or from changes to formulation by the pet food manufacturers if they're willing to put the animal's nutrition above profits. Apple have just released their new thinner, tougher and higher capacity iPhone 17. But there's still no fold version, and AI remains an issue. With the details, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
Well, we've seen in recent times Samsung launches new phones, Google launches new phones, and they've both tried very hard to gazump Apple by launching technologies that should be better than what Apple is launching. But Apple has now launched, and we've seen new iPhones, new watches, new headphones, and new capabilities. Now, let's start with the iPhone 17 Air, which is just called the iPhone Air. It's 5.6 millimeters thin, which is 0.2 of a millimeter thinner than Samsung's S25 Edge. And look, although iPhone and Apple users are going to say that the iPhone Air is better, Samsung really did come out with it a couple of months ago or 3 or 4 months ago, and they have 2 cameras on the back, not just one. Theirs is 5.8 millimeters, so a little bit thicker, but no one's going to really notice that much of a difference. It is supposed to be the most durable phone that Apple has made, and all-day battery life, even though it's got clearly a smaller battery inside. And I noticed that when they launched the all-day battery life claim, in the next scene they said, and we have a MagSafe battery that connects to the back, which is thinner and boosts your video to 40 hours. So clearly it's going to have less battery life. But if you're like me and already carrying around a spare battery for your iPhone 16 Pro Max that has a much bigger battery, well, nothing's going to change. I'm going to still have to carry around a battery. The iPhone 17 and 17 Pro and Pro Max, obviously improvements with cameras and processors and ceramic glass, all very impressive. I think one of the cool things with the Pro Max is that it now comes in a 2 terabyte configuration. In Australia, that's going to take you to $3,799. So you're paying a lot of money for that extra space.
But you want the space, let's be honest.
Yeah, well,
your photos are building up, your music's building up, you need the extra capacity.
Well, as we all know, space is the final frontier, and most people buy a smaller iPhone and they regret it. Now, we also have the new watches. The SE watch, the cheapest one, is now always on for the first time. The Series 11 is thinner than before, and the Ultra 3 has got a slightly bigger screen in the same size case. The last 2 have 5G, not just 4G, and the last 2 can also do hypertension detection. Now, that's not blood pressure monitoring in the sense that you have a cuff that blows up like you have with the Huawei blood pressure watch. But over the course of time, it can detect whether you have hypertension or not if you switch that feature on. And the Ultra 3 can now do emergency SOS. So it's the ultimate watch for somebody who goes out on adventures, and they have a smartphone, but their watch can have longer battery life. In fact, it's now 42 hours instead of 36 hours for the Ultra 3. And it can also do messages via satellite and Find My via satellite. So definitely perfect for adventurers.
Is it far from being an EPIRB? That's sort of what they're aiming at, I guess.
It's pretty close. I mean, an EPIRB will have longer battery life and probably stronger connection to satellites. But a lot of people, if they have an Apple Ultra 3 smartwatch, I mean, yeah, it's effectively an EPIRB. And the extra battery life means they can be out in the wild for that much longer. Similarly, the Series 11 is the first Apple Watch to go from 18 hours to 24 hours of battery life, and that will be extended if you go into power-saving mode. So the watches are an improvement, the phones are an improvement, and then we have the headset. Now, the Apple AirPods Pro version 3 got a sleeker case. It's got a better fit for your ears. They've measured over 100,000 ears. They've got 5 different sizes of silicon tips to make sure it fits any ear. There's memory foam inside to do more noise isolation. We're talking about 8 hours of battery life, which is an improvement. I remember originally when it was something like 3 hours. And if you're using it in hearing aid mode, you now get 10 hours. Apple has increased the longevity of its devices by offering OS updates for years. And it's best if you've got an older device that's several years old. That's going to be the biggest upgrade for people with older devices.
Of course, the elephant in the room for Apple remains AI, doesn't it?
It does. And look, Apple did make references to the fact it does use forms of AI and machine learning and has done for many years. But there was no mention of a Siri chatbot. There's no mention of the deal that Apple is reported to have done with Google to bring Gemini, a customized version of Gemini, to give Siri those conversational capabilities that we take for granted with Gemini on Android devices and with ChatGPT. And also, Apple was meant to have a Magic Q-style system that Google has promoted earlier this year, where it could bring up relevant information about bookings you've made, people you've spoken to, other information that is collected and harvested from different apps on your phone. Nothing from Apple on that. It's promised to come in the future, but they studiously avoided mentioning anything about that. So look, Google and Samsung will say that they have done enough to fight back against these updates from Apple. They have a stronger AI strategy. They also have improved cameras and slimmer devices. They've got the Fold. Yeah, both of them have Folds. But next year, Apple's meant to bring the Fold, and next year will be the year that Apple and Samsung and probably Google will have a Fold that has no crease whatsoever.
That's Alex Zaharov-Reutt from Tech Advice Start Life. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.